Hey, hi everyone. Welcome to the open session 2 for week 2 for the C programming. Am I audible?
Yes, sir.
Yes, sir.
Yes, yes.
Okay, fine. Okay, so today is also a open session. So we will discuss your query, and also I will just discuss about the programming assignment interface of the from the Week 3. Okay. Week 3 is also released, and now the new different types of assignment will introduce from the week 3, that is programming assignment. So I will just explain the overview of the interface of the programming assignments and how you need to solve. Okay, so now we will start from your query. If you have any doubt, if you have any query in the assignments and then contents, then you can ask. You can raise your hand, then we will take your query. Okay, let's wait for 2 3 minutes more. So I think others are joining. Then we will start. Okay, so yeah, if anyone have any query, just raise your hand. I will take your query one by one. Yeah, Alkesh, go ahead.
Good afternoon, sir.
Good afternoon.
Sir, the deadline of the week 1 assignment has been passed, sir,
Hmm.
but it's not graded yet.
It's not graded means.
Means, sir, I
Yeah,
can't see the
score is
marks.
not.
Yes,
Okay,
sir.
okay. So yeah, that actually it takes some time. Okay, so in the backend, the ops teams perform some process, and after that they upload the marks.
Okay, sir.
Okay, so it will update very soon.
Okay, sir.
But you can see the correct answer and wrong answer in the every questions, no?
Yes, sir.
So you can assume you can calculate your score based on that.
Okay, sir.
Okay. So for the MSQ type of question, partial marking is there. Suppose if three answer is correct and you marked only two correct answer, okay, so then you will get partial marks. But by chance, if you select any wrong answer, okay, any wrong option, then you will get 0 marks. So this is the marking for the MSQ type person, multi select type of persons. Otherwise, the other things are straightforward, MCQ and that numerical input. If your answer is correct, then you will get marks.
Okay, sir.
Okay. Yes, Sumant.
Yeah, hello, sir.
Hello, Sumant.
Sir, I have doubt in practice assignment week 2, question number 11th and 12th.
Okay, okay. Let me open and share my screen once. I hope my screen is visible.
Yeah,
Okay, so this one you're talking about, this assembly language code.
yes, sir.
Okay. So, okay, let me just explain line by line. 1 second. Okay, these questions are also similar to your memory model type of questions. Okay, so here assembly instructions are given, but we know that you don't know much about this assembly syntax. Okay, this move, mov, cmp, this al, what is this? So because of that, these comments are also given in the program. Okay, so this is also a program, step by step. So just follow the steps from top to down approach, and just read the comment and perform the operations. Okay, if you don't know the assembly syntax, just read the comment and you can solve this problem. So what we are doing inside this problem, let me see. Increase the font. Okay. So first statement is move r1 comma 3. So what is the meaning of this statement in assembly language is move the value 3 into register r. Okay, so we have some container which we used inside the CPU register. So we have r1 register. Okay, now when the first instruction is executing, what we are doing, we are simply moving the value. Moving the value means we are storing the value 3 into register r. So this means r1 will contain the value 3 in the first step. Okay, now this is the first step. Now move to the second step. Move r2 comma 8. This is also similar to the previous one. So now you can assume that this 8 value will be moved to the r2
R2.
registers. Okay, so that
Yeah.
means r2 will contain 8.
8.
Okay, now third step. Move to the third step. CMP r1 and r2. CMP, what is the meaning of is compare. Okay, so compare the value in register r1 and r2. So we are comparing the value r1 and r2 here. Comparing, what we are doing, if we are comparing now, in the next line, during the comparison, jump to level 1. Level 1 means the first instruction. Okay,
Okay.
level 1, if r1 is less than r2. So we can mark any condition here like this. Okay, so if this condition, if r1 is less than r2, if this condition is true or not, level 1 is not the first set. Okay, so level 1 is given in the instruction. Okay, this last line, sorry.
Okay.
Okay, level 1 means this last line. Yeah, so jump to the level 1 if r1 is less than r2. If r1 value is less than r2 value, if this condition is true, then we will directly move to the step level 1, last step. Okay,
Okay.
so can you check the value? What is the value of r1 is 3. Here is value is 8.
8.
Okay, now 3 is less than 8, correct?
Yeah.
Now directly jump to the last step. Skip this mediator steps, move r3 and this.
R3 5. Okay.
Now what is the last step? Move r3 comma 10. That means in r3 there is one new register r3, and move this 10 value inside r3. Okay, so 10 will store into r3. Move the value 10 into register r3. So this is the step. So now our all instructions are complete. Now what is the question? Just read the question statement. What will be the value
Stored in
stored in
register
register
R3.
r3? When this sequence of instruction is completed, what is the value stored in r3? So can you see in the last, what is the value in r3? 10.
10. Okay.
Okay, so
Okay.
10 will be the answer for this.
Sir,
Hmm?
sir, after in the fourth step, they have mentioned that jump to label 1 if R1 is less than R2 means, if R1 is less than R2 means you will be moving to the step 1. No, sir.
No. Jump to level 1. Level 1 is given in the program. So this is not a step 1. This is a level 1. So level 1 is the last instruction.
Okay, sir. If it is not, if R1 is not less than R2 means,
So then we will move to the next step. This move r3 comma 5.
okay, sir.
Okay.
Yes, sir.
So in that way, we will just execute this. So and we are getting 10 answer. Now the next question is 12th.
Yeah.
So same things we will perform here. So we will perform one by one step from top to down. And first step is move r1 comma 10. Okay, so that means r1 will contain 10 value initially. Now move R2 equal to 5, R2 will contain 5, and R3 will contain 0. Okay, so by after this 3 instruction, we have the value in register R1, R2, R3. These. Now we are running one loop, and loop instruction start the loop. Okay, so this is the one instruction, and we are starting the loop. And how we are performing in the loop? We are adding the R3 and R2 value. So this add R3, R2 means we will add R3 and R2 value and will store the answer in R3. Okay, so we can write this line in that way, like R3 equal to R3 plus R2, like this. Okay, so add the value of R3 and R2. What is the value of R3? 0. R2 value is 5. So 0 plus 5. So that means 5 value will store into R3. Now this value is updated by 5. Okay, by this instruction. By this instruction, this value is updated by 5. Now DEC R1. Okay, that will decrement the value in register R1 by 1. Okay, so what is the value of R1 is 10. So decrement this value by 1. So this instruction we can write like this: R1 equal to R1 minus 1.
Minus 1.
Okay, so 10 minus 1 is 9.
9.
So this value is updated by 9. Okay, and last value is jump loop. Okay, loop back to the start of the loop if R1 is not 0. So we are checking if R1 is not 0, does not equal to 0. We will check this condition. If this condition is true, then we will repeat the process again of this loop. Okay, so what is the value of current value of R1? 9.
9.
So 9 is not equal to 0. That means we will repeat the same process again. Okay, now once again we will check R3 equal to R3 plus 2. Now what is the current value in R3?
5.
R3 is 5. And what is the value of R2? 5.
It's also 5.
5. Okay, so 5 plus 5 will become 10. R3 will become 10 now. Okay, so it will become 10. And next step, we are reducing R1 equal to R1 minus 1. Okay, so now previous value is 9. 9 minus 1 will become 8. So this value will update by 8. Okay, once again we will check R1 is not equal to 0. Yes, 8 is not equal to 0. Okay, once again we will repeat this process. Now once again we will check R3 equal to R3 plus R2. Now what is the value of R3?
It's 10.
10 plus 5. Okay, so 5. So once again I am now getting R3 equal to 15. Correct? So this value is updated by 15. So what pattern we are getting? Every time we are adding 5. R3 value. Okay, so initially it was 0, then it become 5, then 5 plus 5 10. Okay, when it was 0. Okay, so in the okay, so R1 equal to 10. So we can also maintain this R1 value. So R1 initially was 10. Okay, 10 here. Okay, when R2 was 10, then we will reduce R1 to 9, and now value become 10. Now 8, 15. Now we can repeat this process without looping, running by this instruction. We can easily calculate the value. Next step is 7. It will become 20. Next 6, 25. Okay, 5, 30. 4, 35. Okay, 3 and 40. 2, 45. 1, 50. Now still 1 is not equal to 0.
Yeah.
Okay, now next 55. Okay, now 0. So this will become 0 equal to 0. Okay?
Yeah.
So now we will stop this loop.
Yes, sir.
Okay, so during this process, what value we are getting in R3 finally? So this value is 55. So okay, so I think some loop iteration is error. 1 second, let me check again. So in this iteration, what we are doing, we are adding the value R3 first. So initially it was 10. Okay. So initially it's 10.
I think 10 पे R3 का value is 0.
Yeah. Okay. So actually what we are doing, when this R1 was 1. Okay, the value, our value will become, R3 will become 50. Then we are reducing in the last step. Okay, after
Okay.
sorry, after adding this value we are getting 50. Then we are decrementing the value R1. So R1, when we decrement this value 1, so 1 minus 1 will become 0. So 0, and we are checking the condition here. So this condition is not satisfied. So our loop will not run next time. So our loop will terminate after this steps. So last value in R3 will remain 50.
Sir,
Mhm.
sir, until the R1 becomes 0, we should be repeating the loop again and again and again, sir.
No, just check this condition. Jump back to start of the loop if R1 is not 0.
Yes,
Okay.
sir.
So in the last step, here our R1 was 1. Okay. This is the step when we enter the loop. Okay. When we enter the loop again, now our R1 was 1. Okay. This condition is true. This condition was true in the previous step. Because of that, we enter inside the loop. R1 equal to 1. Now
Yes.
we are adding the value. So 45 previous value. Okay, 45 plus 5, we are getting 50. So in this step, we are getting R3 equal to 50. Okay. Now we are decrementing the value in second step here. So now our R1 will become 0. Okay. Now we are checking the condition. Jump back to the start of the loop if R1 is not 0, but here our R1 becomes 0. So this condition is now incorrect, and our loop will not run again. Okay, because this condition is not satisfied. So this is the termination condition. We will go out inside this loop, and at that time, what was the R3 value? So this R3 value was 50. Okay, condition we are checking after adding the value and decrementing the value. We are checking the condition in last. If we add this condition above of the loop, then answer will become change. But we are checking the condition in last. Because of that, the previous value will become result.
Yes, sir. Sir, in the above step which you have mentioned, you are setting up a sequence now, sir. That step alone I cannot get it, sir.
This one, yeah,
Yes, sir.
actually I have written. Okay, so let me clear more according to the code. 1 second. So I am just now writing the value in the step. Okay, so now you can understand. So here what we are doing, we are updating R3 value. Okay, here we are updating R1 value. Here we are checking the condition if R1 does not equal to 0. Correct? In these
Yes,
three
sir.
steps. So initially, before entering inside this loop, the value was this R1 was 10, R2 was 5, and R3 was 0. This is the previous. Okay. At the time we are entering inside this loop first time. Now when we are entering inside this first loop, so at that time R3 was 0, and we are adding the value of 5. 0 plus 5, so it will become 5. Correct?
Yes, sir.
Okay. And we are decrementing the value of R2, sorry, R1. Okay, by 1. So previous value of R1 was 10. Now it will become 9.
9.
Correct?
Yes, sir.
Now we are checking condition. 9 is not equal to 0. Yes, true.
Yeah.
Okay. Now we will again repeat the process here. So this is the first iteration. This is the second iteration of the loop. Second iteration of the loop. That means now the value of R2 will remain always 5. Okay. We are not updating R2. What we are doing, we are updating R2 in R3 every time. So previous value of R3 was 5. 5 plus 5, it will become 10.
Yes,
Okay,
sir.
by this step. Next step, 9 minus 1 will become 8, and
Yes, sir.
8 is not equal to 0.
0.
Okay, so that means if this condition was true, this condition was true once again. Okay, now we will enter again in the loop 3. Now it will become 15, it will become 7, and condition is still true. Okay,
Yes,
now fourth iteration, 20, this will become 6, still condition are true. Now fifth step, 25, and 5, and condition is still true. Okay, now next 6 iteration, 30 and 4, and this is true. Now 7th iteration, 35, 3, condition is still true. Okay, 8, 40 and 2, this is true because 2 is not equal to 0. 9th iteration, 45, 1, okay, still condition is true. Now once again we will enter inside the loop. Now 50, it becomes 0, and now condition is false. So we will stop at this process. Okay, we will
Yes,
not repeat again. So at that time you can see what is the value of R3, 50.
50, sir.
Okay, so because of that we are this 50 is coming in the answer.
Yes, sir.
Clear?
Yes, sir. Clear, sir.
Okay. Yeah, Bhavesh.
Hello, sir. I'm
Yeah,
audible.
Bhavesh. Yes, you are audible.
So question number 7 of week 2 practice assignment.
Okay. This one. Decimal equivalent of the binary number. Okay. So you know if binary number is, if decimal number is given, how we can calculate the this decimal, or decimal is given, then how we can calculate the binary?
Divide by 2.
This division method we can use, or okay, for this when decimal value is given. Okay, so what is the decimal equivalent of the binary number? So this is given as a binary number. Okay, now we want to calculate the decimal for decimal equivalent of this binary number. So how we can calculate? So for the part which is coming before the decimal, so what is the process to calculate the value for this? So 1 0 1 1. Okay, and another part is after decimal is 0 1 0 1. So what we can do, we can write the steps to calculate the value. So for this position, we will write 1 into 2 to the power 0. Okay. For second step, we will write plus 1 into 2 to the power 1. Plus for next 0 into 2 to the power 2. And this is the step 1 into 2 to the power 3 plus. So this is for the side before the decimal side. Okay, and for the after, so how we can represent for the after? 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 0
Sir,
into 2
got
to
it.
the minus 3 plus 1 into 2 to the power minus 4. Got it? So now calculate this one and calculate
Yes,
this
sir.
one.
Yes.
Then you will
So
get the
question
answer.
number one more question, sir. Sir,
Hmm.
question number no, it will also solve.
Question 8.
Sir, question
Yeah.
number 10.
Anyone is asking 8 number? Question 8?
Yeah.
No, sir.
Okay. Okay, someone is asking. Let me just take the query. Okay, the sum of two unsigned binary numbers is this one. If one of the number is this one, what would be the value of other number? Okay. Okay. So sum is given. This okay. One of the number is this one, and what is the value of? Okay. So can you convert this binary number into a decimal number?
Yeah.
Okay, so simply calculate this number into a decimal number, and this one also. Then you, after converting the decimal number, you can simply find out the second number. So what is the decimal value for this? Okay, so you can simply write 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3 plus 1 into 2 to the power 4 plus 0 into 2 to the power 5 plus 1 into 2 to the power 6. Now calculate the value. So this is 1 plus 0 plus this
4
is 4 plus 8 plus 16
plus 16
and this is 0 plus
plus 64.
64. Yeah. Add this value 80, 88, 92, 93. Correct?
Yeah.
Okay. Similar to for this one. Okay. So I'm writing the steps only for one. So 2 to the power 0 plus, and for this one, okay, so 0 1 2, 2 to the power 2 plus for this one 2 to the, sorry, no, 0 1 2, okay, 2 to the power 3 plus 2 to the power 5.
5.
Okay, so 1 plus 4 plus 8 plus 32. What is the value of this? 40,
45.
44, 45. 45. So just subtract it. What value you are getting?
48.
Kitna?
Yeah,
48.
48.
48. Okay. So 48. Now convert this into a binary. So what is the process to convert decimal to binary? Is just use the division method. 48 to 24. Okay.
Yeah.
Here 0 to 12 0 and 2 6 0 2 this set 0 3 now 2 1 and here 1 and 2 now 0 and 1. Okay, now just read in that way, bottom to up. Okay, so what value we are getting? 1 1 0 0 0 0. So this should be the answer for this. Okay, can you see?
Yeah.
This is the answer. Okay.
So question number
Yes.
10.
Yeah.
Can we not solve this by just subtracting the primary method?
Is it you are not properly audible? Can you repeat?
Sir, can we not solve this question by just subtracting the two binary digits?
Yeah, that level actually. Otherwise, that things is in deeply you have to learn when you learn the computer architecture. We are not including all the things. We can also perform the addition, subtraction, all these things on the binary number, but that is not required for this C programming course.
Okay.
Okay, later you will learn all these things in the digital electronics course. Yeah, Dhruv.
Sir, I am having a doubt in week 3 practice assignment, question 7.
Big 3.
Yes.
Okay, I'll come on the big 3 later. First, I'll just take the query of big 2. Okay, I will also explain the programming assignments interface, and
So question
then I'll discuss. Yeah. Yes. Question number.
Question number 10 of week 2.
This one. 2s complement.
Yes.
Okay. So here binary number is given and asking that what is the 2s complement of this. So for the 2s complement, to calculate the 2s complement, what we will do, we will calculate the 1s complement. So 1s complement, for the 1s complement and plus 1. So this is the way to calculate 2s complement. First calculate the 1s complement of this number, then plus 1. And what is 1s complement? 1s complement is just invert all the digit and 0 to 1 or 1 to 0.
Sir, I forget the concept you tell that if we add 0 to 1 then it become 1, and if we add 1 and 1 then it become 10.
No, this is not related to that AND or operation.
Oh, okay.
Okay, which I just discussed in the Monday session. This is just a invert the digit 0 to 1 or 1 to 0. So you will get 1s, then add 1. Okay, so in this process, if we invert all the digits 0 to 1, so we will get 1 1 0 0 and 1 0 1 1. Okay, here 0 1 1 0 0 0 1 1. Okay, this is the invert process. I have just inverted all the digit, and after that, so this is a 1s complement, and after that we will add 1. So by this, when we add 1 to 1, so we will get 0. Okay, and we are getting 1 carry, and after that we will just adding this 1 and 1, then we are getting 0, and once again we are getting 1 carry, so we will pass here 1. So this is the process to add 1, and after that we will write the same things: 0 0 1 1 0 1 1 0 1 0 0 1 1. Okay, so this will become 2s complement.
Okay, sir.
Okay, yeah, Harshit, raise the hand, Harshit. Harshit Porwal.
Sir, I asked question big 2 graded question number 2.
Graded.
Yes, sir.
Let me check the question. Well, I think deadline is not over. 11th is the deadline. Question number 2 you are asking.
Yes, sir.
If the hexadecimal representation of a decimal number is 8-bit sign magnitude format is 84, then the decimal number D is. So have you learned this sign magnitude of hexadecimal number 8-bit? In this question, what you can do, so here the hexadecimal representation is given, this 84. You can convert it into decimal number. Okay, you know how we can calculate hexadecimal to decimal?
Sir, what?
In this question, one decimal number is given D, and the hexadecimal representation is given for that. Okay, with the sign magnitude. Okay, so this is 84. So first calculate the decimal representation, and then check then the decimal number. Oh, the decimal value is asking that here. So just convert this hexadecimal to decimal.
Sir, firstly,
binary form and
sir, firstly convert into binary this hexadecimal.
Yeah, you can also do the process. You can convert into a binary, hexadecimal to binary, then binary to decimal. You can also do this.
Sir, how to convert this hexadecimal into binary?
So this is the simple representation. Okay. So in the hexadecimal, every digit we represented by 4 bits. Okay. So 0 we represented by 0 0 0 0. Okay. 1 we represented by 0 0 0 1. 2 0 0 1 0. 3 0 0 1 1. 4 0 1 0 0. Okay, so this 4 is the equivalent of this 4. If you calculate the binary for 4, you will get this code. Okay, 1 0 0. But we will always represent it by 4 bits for each digit. Okay, so 5, this 0 1 0 1. 6 0 1 1 0. 7 0 1 1 1. 8 1 0 0 0. 9 1 0 0 1. But after 10, so 10, so if I'm writing this in hexadecimal, okay, so 10 we represented as a. Okay, so this the binary bit will be 0 1 0 1 0. Okay, now B, so this means 10 11 12 13 14 15. Okay, A B C D E F. So the binary representation is 1010, then 1011, 1100, and 1101, 1110, and 1111. So this is the mapping of the. So that means hexadecimal means we have different types of total 16 digit, 0 to 15, and we can make the number using this 16 digit. What is the meaning of binary? We have only 2 digit to represent any number, 0 and 1. In decimal we have total 10 digit, okay, 0 to 9, 0 to 9, and we can represent any number with the help of these 0 to 9 digit. Similar for the octal number. There's one more number system is octal. In octal we have total 8 digits, 0 to 7, and we can represent any number in using this 0 to 7 digit. In hexadecimal we have 0 to 15, okay, this total 16 digit, and we can represent any number with the help of these 16 digit. Okay, so this is the number system, but in hexadecimal we will not write this 10 after 9. Okay, we will just have given the number A, B, C, D, E, F, okay, after 9. So now this number is given 84. Okay, suppose how we can convert. I am not taking this example, I am taking any other example. Suppose if any hexadecimal number is given like x0 and not x0, I think 0x. 0x. So this 0x is just a notation. It represents the values in hexadecimal. Suppose value is given like 8a. Okay, so this value is given 8a is a hexadecimal value. How we can convert this into a binary? So you can simply convert this into a binary. You know that every digit in the hexadecimal represented by 4 bits. So just convert 8 into 4 bits and a into 4 bits. So what is the 4 bits equivalent of a, which is 1010. Okay, so that means you can simply calculate the binary number for the 10. Okay, so which one which is this 1010, and write the binary number for this 8. Okay, so what is the value of 8 in binary is 100. Okay, but we will take as a 4 digit. So now we are getting this is a binary equivalent of this 8a. Okay, now you can also convert this into a hexadecimal, decimal equivalent. So decimal, you know that how we calculate this binary to decimal. Simply apply the 2 to the power 0 like this.
Sir, binary number of 8 is 1000 should be.
Oh, I have written wrong. Sorry. Yeah, correct. Yeah. Yes, this is the binary of 8. Sorry. 1000 and 1010. So this is the equivalent of 8 and this is equivalent of A. Okay, so this is the binary of this binary equivalent of this 8a. Okay, for that problems, actually it is given that the number is a sign magnitude. So that means the first value will represent the sign symbol 0 or 1. Okay, so 0 for positive, 1 for negative. So if we want to calculate the decimal value for that, so that means just remove this value as a negative, consider this value as a negative, and calculate the decimal part for this. What is the decimal value for this part? Okay, so you will get the answer for that question. Okay, so the same thing.
Excuse me, sir.
Sir,
we'll convert that binary number to in terms of sir, which number?
Binary number to which question you are talking about?
Yes, sir. This one.
Yeah, here this is given as a hexadecimal. Okay, we have converted this into a binary number. The binary equivalent of this 8a is 1000 and 1010. So this is the binary equivalent of this 8a. But in the question statement, it is given that this number is actually a sign magnitude number. Okay, so that means sign is also given, negative or positive. So that means one value, one bit we are using for the sign. So we will just consider the first digit as a sign. If this is a 1, that means value is negative. If this is 0, the value is positive. And the remaining value is actually indicating the number. Okay.
Okay, sir.
So you can do these things for this person. So just calculate the binary representation for this 84 and check the answer. Okay, so just practice on this number conversion: binary to decimal, decimal to binary, binary to hexadecimal, hexadecimal to binary. So these are the important topics in the terms of the quiz 1 and qualifier exam. Okay, so maybe 1 or 2 questions you can expect this number conversion.
Sir, I also doubt in question number 5 asked.
This one?
Yes, sir.
This is graded. You are talking
Yes.
about this graded question. Okay, so if you have a document which contains only uppercase and lowercase alphabet, space and comma, how many bits are required to encode a character such that the size of the document is minimum? So what we are using? We are using alphabets up in uppercase and lowercase. Okay, so how many alphabets we are required? After that, we are also using space and comma. So there will be 2 more. Then how many total different characters we have when we include all these? Then just check that value can be so how many bits are required to represent that value. This is very straightforward question. If I just explain more, then you will get the answer for this. Okay, so I'm taking another example. So suppose if we have a one character set, okay, so character set can be anything. We are using any different types of symbols, and we have a total unique symbols are total 128. Okay, in our set. So how many bits are required to represent this 128 value? So just calculate the binary for this 128. Okay, so just check after calculating the binary value for this, then you will find out the total number of bits required. So minimum bits. If you are getting 0 initially, like you are getting 1 0 1 1 0 1 0 like this, you can ignore this because this is coming as a initially. So no need to. If you remove this, still the value will be same. Okay. So how many bits are required? So 1 2 3 4 5 6 7 8. Total 8 bits are required to represent this total 128 numbers. This is just I'm taking example. Not this is not the answer for this 128. This is now the question for you. What is the binary equivalent of 128? For a small example, we can take like if we have 4 character set, okay, 4 unique value. So how many bits are required to represent 4 value? Only 2. So 0 1, sorry 0 0 0 1 1 0 1 1. So 1 for this, 2 3 4. Okay, so we need only 2 digit, 1 digit, second digit. We need maximum 2 digit to represent 4 different characters. So similarly, that question is depends on this information. I hope so you get some idea. Okay. So these are great questions. So I cannot explain too much, but I think you will get some idea now. Yes, Saurav?
Sir, I have program in question number 12th practice assignment week 2.
But I think I have just explained this question in the initial of the session. Can you just go back into the YouTube and see the
Okay,
explanation
sir.
of this? Okay.
Okay, sir. Okay.
Yeah, in the starting of this session, we have explained this 11th and 12th.
Okay, sir. I will say.
Okay. Okay. Any other query? Okay, in Beak 3, I am just explaining that. So now the similar of the Beak 2 and Beak 1, you will get quiz, okay, practice assignment and theory assignment in the quiz form, this MCQ, MSQ and numerical input type. So this is the similar things. Okay, similar type of questions, practice assignment and graded assignment. Now the one new things is introduced, this PPA1, PPA2, this step, these questions. Okay, so PPA means practice programming assignment. Okay, and in lower you can see also 2023 term 3, this GRPA3, okay, graded programming assignment 1. So above 5 questions are actually practice programming question, and lower 5 is GR, which is mentioned that GRPA, these are graded programming assignments. So that means marks will be included for this graded assignments in your score. Okay, so for this, from this Beak 3 onwards, how your marks will be calculated? So 50% from your theory assignment and 50% from this 5 assignments average score. Okay, now what is the interface? I am just explain one interface. Okay, when you click on this programming assignment, you can see the problem statement here. Okay, you can see the problem statement. In the Beak 3, we are asking to write only simple expression or basic without any control structure or loop or anything. We are asking to write only simple mathematical expression in the C language. Okay, we are not asking any tough questions. So here, complete the program. This is the problem statement is given. Okay, and one sample input is given to the problem, and what output should be come when we are giving 5 input. Okay, so just read the problem statement, understand the problem statement, and this input will be given, not this only, this is one sample input. If we are giving 5 input, output should come 15. So now you can see the structure. Most of the program is given to you. Okay, initial part. So this a graded part. Okay, so this actually, this part is a prefix code and this is a suffix code. That means some part of the code is given. You can write your code in between. Okay, with this white line which are coming in between. So you can type here. Okay, if you want to add more line, you can write here. Okay, in that way you can add. You cannot remove this previous code which is already written. So in this part, you have to written something, so this code will become complete. Okay, now in the Monday session, I will just explain the programming things, how we can write the basic structure of the program, and we will just explain everything for the programming thing, and then you can start the coding for the Beak 3. And the Beak 3 content is also related to the expression, operator, variable, this basic things for the C programming. Okay, so I will explain some practice problems on the Monday session. I will also explain this structure, what it is represented actually. Okay, which is already written in the code, what it is represent, what is scan meaning, what is the int meaning. I will explain everything in the Monday session. But here for the structure, you have to write some expression, mathematical expression here in this white space in between two this shaded space, and then it will become complete, and then you have to click test run button. So there are 2 types of test case are configured in this for this problem. One type is public test case. So public test case are actually visible to you. So public test case means what input we are giving to the program and what output should come. If we are giving 5, output should come 15. If we are giving input 10, then output should come 55. Okay, so these all inputs are visible to you. Expected outputs are also visible to you. When you click on this test run button, your code will produce some output. That output will come in actual output place. Okay, so now you can also see that what expected output is and what your code output giving. If both are similar, then that means this test case is passed. If both are different, that means test case is failed. Your program is not returning correct output. Okay, so these are public test case which you can see, okay, and which you can verify that your code is returning correct output or not. After that, there are some more test case are configured in the hidden form. That is actually called the private test case. Okay, private test case, which you cannot see, but the input is the similar type of this public test case, but you cannot see what is the actual input we are giving to the program. But if your code logic is correct, if your expression is correct, if your code is providing the correct output for the public test case, okay, so that means the private test case should also be correct if your logic is correct, okay, in the program. So after clicking on this test run button, you will get the message. You can also see the actual output in this platform. If you are satisfying that all the test cases are passed, your logic is correct, then you can click on the submit button. So submit button is actually for the running the private test case as well as the public. So this submit button will run the public test case as well as the private test case, and will show you the status of your private test case. How many private test cases are passed or how many fails. If all private test cases are passed, that means your program is correct and you can leave this program and you can move to the second program. If your private test case is not passed, then you have to revisit your solution, and then you have to check where you are doing the mistake. Okay, so this is the interface. This is the editor part where you can write the code. You can just increase the font, decrease the font, and you can also just increase this screen, okay, to write the code. And this is copy, paste, cut, some functions are given. So you have to, and before writing the code, you have to select the C language from this box. Otherwise, this box will actually come in the blank screen. Okay, you have to first select the language here, C. When you select the C language, this part is visible now. Okay. So for this is the second question. You are given float value for principal, rate, time. Yes.
Sir, apart from this programming assignment, below the page they have given something known as the supplementary content, sir.
This one?
Yes, sir. If I access that, the files are little jumbled, sir. I cannot access it properly.
Jumbled means when I'm clicking this. So
after I click the download now button also.
So you can click on this. New interface will open. You can see two files.
Yes, sir. If I try to open the first file or even second file, the details are not given properly, sir. I cannot
actually the file size is very high. You can do, you can just simply go here and download the file.
Okay, sir.
Okay, this is 47 MB file, 50 MB file, so maybe it will take more time to load. So just go to the download button and just download in your system, and you can see the locally.
Yes, sir.
This is simple PDF file, which is used in the lecture video.
Okay.
Okay, so use that after the downloading. So yeah, this is the thing. So in the programming assignment, so now I'm just giving some example by running these things. So simple interest. So if you check this program, you are given float value. Float means decimal value. Okay, so principal, rate, and time. Calculate the simple interest and store the result in the float variable simple interest. Okay, so this formula is given to calculate the simple interest. Now you have to written this formula in code. So everything is given, you have all the values. Okay, now you have to write this formula in the programming language concept. So the what is the principal rate and time. Okay, so principal rate and time and 100. Okay, so simple interest, so the variable is not declared, so you have to use the variable like, so like float simple. I will explain in detail. Okay, so in the Monday session I'm writing one code equal to, and we will write the same expression principal into rate into time. Okay, so princi uh princi principal into rate into time.
Sir, it is PRINCIPAL.
PAL. Okay, yeah, yes, PAL, correct. And divide by what is the value? 100.
Spelling of a simple interest variable. The double E. Float.
Okay. SIMPLE I and okay, sorry. Yeah. Right. So actually this value, this variable name should be matched by this given variable in the program simple interest is. So I have written this expression. Okay, I am just increasing the font. You can see. So the initial program is given. This in suffix programming is given. You have to write one only expression to complete this program. Okay. Now simple interest equal to principal into rate into time divided by 100. So this now program is completed, and after that you can click on the test run button.
So semicolon after in 8 line.
Yeah. So this is giving some error. Okay. If your code is not following some rules of the C programming language, so it will give some error. Now you can complete this by semicolon. There are some rules to write the code in the C language. We will discuss in the next session. Okay, so now this is complete. When we click on this, now you can see here actual output is also coming now. Expected output, and this is the actual output which is coming from your program which you have written here. Okay, so now if both are met, you can see both are the same value on the left and right for the all. So the status is also mentioned here, 5 out of 5 passed, public test case. Okay, if you feel that your code is correct and all the public test cases are also passed, now that means your logic is correct, then you can click on this submit button. Okay, now this one message will come, submission successful, 5 out of 5 private test case pass. So if you are getting this message, that means your this problem is completed, you will get full marks for this. So marks are also associated with private test case only. If you are getting one private test case pass out of 5, that means you will get 20% marks for this problem. Okay, so let me just incorrect something. So I'm just changing this divide value, okay, by 10. Now I'm just writing, I'm running this program by test run button. Okay, now you can see the value is coming different here. 500 should be come, but your code is returning 5000. Okay, so output is coming, but output is not matched with the expected output. So now you can see the status, public test case 0 out of 5 passed. Okay, so that means your output is not correct. So you have to revisit your program, you have to check your logic or expression or all the things are correct or not, and then you have to modify your program. Okay, now when you completed it, and also when you click on the submit button, okay, so status of the private test case will also come 0 out of 5 private test case passed. Okay, So this is the procedure to do the programming assignment and how you will the interface. Okay, so in some question this prefix and suffix program is given. So in maybe later questions, so in the graded questions. Okay, this problem statement is given, some equation is given, some input and output format is also given, sample input is given, and then you have to select C. And you can see some part of the programming is given, and also comment is also given. So you can also understand that what we are doing in which part. So what we are doing in the first part, what we are doing in the second part, and here you need to write your code, and this is the printing the output. Okay, so just see the code which is already given. Also read the comments and just understand that what this code is doing actually in each step. Okay, so some problems are given with this suffix and prefix code. After solving this practice assignment and this graded assignment, second is also given with the code. Okay, now from third problem, so code is not given in the editor actually. Okay, code is not given in the editor. Some template is given in the problem statement itself. Okay, you have to write this, and after that comments are given. Just follow the comment and complete the program. Okay, according to the problem statement. Okay, so write the complete program in this editor, and you can take the help of this template to write your program. Okay, so we will discuss all these things: operator, operand, variable, all these things in the week 3 content. So just see the week 3 videos, and we will take the lecture session on the Monday in detail for this. Okay. So this is the interface for week 3 programming assignment. If anyone have any query, yeah, someone was asking any query from week 3.
Yes, sir, from practice assignment, question 7.
Okay, so have you watched all the videos?
But actually, I did it in qualifier phase.
Okay, you have already did. Now you are term student.
Yes. So question 7.
This one?
Question 7.
Yeah, this one, no? Practice assignment. I have opened the question 7.
Yes, sir, I'm getting -8 in this. And the answer is -9.
Okay. Okay, what you can do if you have already learned, so that means you have already learned in the programming assignments also. Okay, you have already done, I think, in the previous qualifier, correct?
Yes.
Can you just write this code in the editor and just check what output is coming?
Okay, sir, I'll check it out.
Okay,
But
because
if you can
the
explain
things actually other
its
things are
logic.
not discussed. Other things are not discussed related to the week 3 content. So because of that, I am not starting these things today. Okay, so we will discuss all these things in the next week once you all have watched the videos. And okay, so it otherwise it will create a confusion, so that we maybe will not understand what happening.
Sir, can I ask a doubt?
Yes.
Sir, in week 2 there is representation of 0xFF. Like, I'm not understanding this one.
0x is just represent the hexadecimal representation bus only.
Yes,
This
please.
is the notation of hexadecimal. I have just explained this. If any number is given with this notation 0x, so this is just a notation that after that which is written. Suppose if here it is written 845. Okay, 0x 845. So that means this is just representing that this number is hexadecimal number. Okay,
And
you have nothing to do with this. Okay, 0x. You have just if this is given, that means this number is hexadecimal number.
And sir, F indicate?
So in hexadecimal number, I have just mentioned this representation, this one. Okay, so f is represented 15. Single f is represented 15 value in decimal. Okay, if you have 4f, so f f f f. Okay, so this is a hexadecimal number where each f is represented 15 in decimal. This is just a hexadecimal representation for 15. Hexadecimal means we have total 16 unique digits to represent any number.
Sir, can we represent any number in hexagonal representation?
Yes, we can represent any number in hexadecimal.
Sir, can you take 8-bit example like 1 1 1 1 0 0 1 1?
Okay, 1 1
1 1
hmm.
0 0 1 1.
0 0 1 1. This is binary number.
Yeah. Now it's converted into hexagon. So
hexadecimal. So this representation is very simple in the binary to hexadecimal. Just read the value. Are you asking any question from assignments?
No, sir. No, sir.
Okay. So what you can do, you can just so every hexadecimal digit is represented by 4 binary digit. Okay, so this f we are written, so we can represent it by this 4 1. Okay, so this mapping is, I have just mentioned that this f is representing 15, and what is the binary equivalent of 15? This one. Okay, before this e is represented 14, and binary representation of 14 is this. So in hexadecimal number, every digit is represented by 4 bits binary equivalent. Okay, so if this binary representation is given, okay, so just pick 4 digit from the right to side. Okay, so from the right side, just pick the 4 digit and again pick the 4 digit. Suppose if in the next 5 digit are given, okay, so I am taking another example like 1 1 1 1 1, okay, and 0 0 1 1, like this. Okay, so just pick the 4 digit first, pick the next 4 digit, pick the next 4, but if next 4 are not available, just add 3 0 and then pick. Okay, now just check what this value is representing in hexadecimal. So this is for 3. Okay, what this is representing f, and what this is 1. So 1f3 is the answer for this in hexadecimal.
Sir, or we can write it as 0x 1f3.
You can write as 0x and 1f3 in that way also. Okay, so this is the hexadecimal.
Example of 32-bit.
32 bits means okay, so 32, what is the meaning of 32 bits? So we have total 32 bits. So how many digit can come in 32 bits? Because for each digit of in hexadecimal required 4 bits.
Yeah. So
okay, so that means 832 divided by 4. 8 digit you can write in hexadecimal.
Yes, sir.
Okay, so you can write like this: f f f f f f f f. So this is 4, this is 4, yeah, total 8. Okay, so 8. So total bits are required 32 here, and this is actually 8 hexadecimal digit.
Okay, sir. Thank you so much. Thank you.
Okay.
Sir, I tried to solve question number 7, big to graded, but not solved.
Week 2 graded. Question number 7. So here actually some number system is given. What is this instruction? Okay, so instruction code. That means 2 digits are required to represent the instruction 0, 1, and 2. Okay, and 5 bits are required to represent this operand. Okay, so that is information is also given. So if value is coming in between 0 0 0 0 0 to this number, so represent the value of 0 to 15. this is the value, and if next 5 digits are coming in this range, that is are representing the registers. Okay, and final instruction has this okay, so our instruction is created by this. First we are taking the instruction code, then we are taking operand 1, then operand 2. The total bits are required 12 bits. Okay, let me just take some example for this. So here actually one instruction is this instruction structure is given, where first place we are taking this instruction code, second place we are taking operand 1 and operand 2. Okay, so this operand 1 and operand 2 is coming in from this coding, this part. Okay, and total 12 bits are required to create this instruction. So that means first 5 bits. Okay, so instruction, sorry, not first 5 bits, first 2 bits. Okay, 2 bits are creating, representing this instruction set. Okay, next 5 bits are representing first operand. Okay, so 5 bit, and next 5 bit is representing second operand. So operand means either register or either value from this 0 to 15 range, or R0 to R15 range. Okay, so how instruction can be created? Suppose our instruction is add instruction. Okay, so add instruction value is 1. So how we can write this 1 value in binary 2 digit, which is 0 1. Okay, so we can write this 1 as a 0 1, this is as a 0 0, and this 2 is a 1 0. Okay, so this is the equivalent binary of 0 1 and 2. So 2 bits are required to identify this move, add, and sum. So if we are taking add operation, suppose we are writing okay, in hexadecimal this answer is asking. Okay, so I'm taking another example. Suppose I am writing sub, okay, R6, and another is like 10. Okay, this instruction is given. So what binary representation will be written for this instruction? So sub is actually a this 2. What we will write 1 0 for this. Okay, now R6 means, so R0 value is representing by this value. Okay, 1 0 0 0 0, and we need code for R6. So what will be the next value for this? 1 0 0 0 0. So this is the for R0. Okay, now if we want to write R1, R2, R3, R4, R5, and R6. Okay, so that means we have to write the code for 6 here. Just increment 1 in every time. So 0 0 1, 1 0 0 1 0, 1 0 0 1 1, 1 0 1 0 0, and so this will become 4, and 1 0 1 0 1, this will become 5, 1 0 1 1 0. Okay, this will become 6. Now next, so this is 2 digit. Next 5 digit will be 1 0 1 1 0. Okay, so this is representing R6. Okay, now we want to take code for 10. So 10 code will come from this above. Okay, so 0 0 is starting is, so 0 0 0 0 0. Okay, 2 0 1 1 1 1. So that means what will be the value for 10? So 10 value will be 0 1 0 1 0. Okay, so this is the representation of 10. So next 5 digit will be 0 1 0 1 0. Okay, now this 12 bits code which will be created for this instruction, sub R6 and 10. Okay, and when we are writing this 12 bits, how we can convert into a hexadecimal? Simply I am writing the same instruction into 1 0 1 0 1 1 0 0 1 0 1 0. Okay, after combining, just to convert this into a hexadecimal, take 4 bits from right. Okay, so 4, then next 4, and then next 4. So what is this equivalent of? A. What is this equivalent of this one? This will become C, I think. Okay, so let me check 1011. Yeah, this will become C. Okay, and this will become A. So ACA is the hexadecimal representation of this instruction. You can calculate it. Okay, so what is given here, the instruction is given, will be represented in hexadecimal as. Okay, so just you can calculate in that way.
Sir, they have said that final instruction will be having two operands, no, sir?
Two operands. So two operands means the operands. So both. So there is one set for this value, and there is one set for the registers. So both actually considered as a operand.
Yes, sir. So in the answer, we will be having totally 4 types, sir. First, they will be add and R4. After that, 5. After that, something will be there, sir.
No, I'm not getting what you're saying. That
the final instruction has the structure they have given. Instruction code first and operand 1 and operand 2. After that, 12 bits, no, sir.
No, this is not 12 bits. Actually, this is just an identification that total bits are required for this set is 12 bits.
Okay, sir. Yes, sir.
Okay, this is not the included in the instructions.
Yes, sir.
Okay. Yeah, Arunya?
Yes, sir. Am I audible?
Yes, you are audible.
Sir, actually, it's not related to the week assignments. I have a personal query. They in the lab dates, they are clashing with my end-term exam of offline degree.
Okay, this lab dates are declared.
Yes, sir. 7 to 10th December and 14 to 17th December.
So there are 2 slots, and both are clashing.
Yes, sir. My exams are from 25th November to 18th December. But I don't know what are the dates in between. Like they have just declared the pattern in which the exams will come. Right now, I just know that much. It will be between this date.
Okay. If you are facing this type of difficulty, just write a mail to the support team.
Sir, I have written the mail, but they are saying right now we only have these 2 slots. So I have.
So they will provide some alternative. Okay, so if your other exam is going on, so you can also not do anything. So just wait for that. Okay, and just write the mail what you can do. So
okay,
this
sir.
is the problem for
sir, I have a query. If there are no any other slots and I can't miss even my exams, so if I miss my lab, will I be failed in the course?
No, your course will be incomplete actually, not failed. Okay. But I grade you will get. So once you complete your lab assignment, so then
in the next semester I can complete these labs.
Still the all the things are not clear. Maybe they will provide some alternate. Okay, for this type of query.
Okay, sir.
Yes.
Thank you, sir.
Okay. Yes, Saurabh. Yep. Prajwal.
Query I'm in qualifier phase. So there are eligibility criteria that you must score in qualifier exam. You must score greater than 70% to be eligible for four courses.
70%? No. I think this is not correct.
Nah, actually, in the site there is written
70%. I am not sure that 70% is required.
Sir, I think it is 40%.
Yeah, 40% is required in each.
No.
4 courses.
He's telling about the
Okay.
Course creating.
You are telling about so how many courses you can take?
Yes, sir.
After qualifying the course.
Yes,
okay.
Sir. If I didn't choose 4 courses, so my BS degree will be not considered.
No. This is not. This is just a suggestion. If you are getting less marks, so select only 2 courses or like this in one term. So this is based on your marks. This is just a suggestion which is giving by us, that just take 2 course or 1 course in 1 term. Otherwise, maybe this will become difficult for you if you are taking 4 courses at a time.
Yes, sir. What is the difference between a guy who's choosing 4 courses and a
Nothing difference. Actually, maybe he will complete earlier before those who are taking only 2.
Sir, is the degree can be finished before 4 hours?
4 years, you are saying that?
सर डिग्री 4 साल से पहले भी खत्म हो सकती है अगर कोर्सेज जल्दी लेते रहे.
हाँ, actually the degrees depends on the total number of course, and
Credits.
I think in 1 term you can take maximum 4 courses. Okay.
Thanks for
And otherwise you can also take less number of courses, like 1 or 2 or 3 courses, because maybe most of the students are doing other courses, offline courses also. Okay, so it may become burden on you if you are doing the offline courses and you are taking 4 courses from this program. So
Sir,
maybe
can I-
it's difficulty to complete all the courses and getting good marks. So
So
because
can
of
I
this,
ask question about placement?
just this ES is actually just started.
Yes, sir.
Okay, there's no
Can
I think this is the
can
first
I
batch.
ask something?
Mhm.
Yes, sir. So we will get placement.
Yeah, definitely, if
we get
they are providing some course from your IITM, definitely they will create the separate placement team and they will provide to the opportunity.
Sir, can some point of time we can compete with the regular IIT students or not?
Regular IIT means?
Sir, can we compete with the student who are studying in IIT in regular
Yeah,
courses?
definitely. You will get the degree, and this degree is actually valid. Okay, so you will become alumni of the IITM. Okay, so you can also sit with the IIT students, and you can. But definitely, in the finally, your knowledge will be tested. If you are sitting in any placement, definitely they will check your knowledge, what you are actually gaining.
Okay, thank you, sir.
Okay. Yes, Saurabh? Saurabh, you raised the hand. Any other query? So today we have to finish at 4:30 because I have another session. Okay, so we will conduct a session on Monday where we will discuss all the things which are required for the programming. Okay, so the basic program writing. Okay, so please attend that session, and we will also discuss the programming assignments. Okay, if there is no query, then we can wind up the session.
Thank you, sir.
Yeah. Thank
Okay,
you.
sir. Thank you.
Everyone. Thanks.